Hello and welcome to this series of videos on using version control tools in your projects. This video will serve as a introduction to what exactly version control is, so it will serve as a nice reference if you're ever confused about what exactly we're doing. First and foremost, let's just focus from a product standpoint. So why do we want to engineer good products? Well, as we all know, software and companies thrive off their products. So their product is their lifeblood. If we have a very successful project, a very successful product, the software company will attract consumers that like their product, and in turn, hopefully make money, make revenue. And we can use this as a competitive advantage over the competitor. Now, the term product quality or software quality is very vague because how exactly do we measure quality? Right? We could have one piece of software that looks beautiful, that it's designed really nicely, the UI is amazing. We have another product that's a very basic UI and doesn't look very good. But that basic UI and that basic project could be releasing features day after day of updates, while the very nice looking product is releasing features after a month, right? And there could be just simple ones which were done in a day in another product. So that's one metric of quality we can use. And that's maybe a marketable advantage over their competitors. And we want this so that we can avoid bugs, right? So bugs are a sign of low quality software, not one bug, maybe a few dozen bugs which really ruin the experience of a product, and this could damage a business's reputation. So obviously we want to avoid this. So we want high quality software and we want to minimize bugs as much as possible. And really, to achieve high quality software, we need to achieve high quality building the software. So we need a high quality software engineering process. So the software engineering process is defined in many ways. The definition I'm going to go with here is, we've got the requirements phase, we've got the design phase, implementation, testing, etc. And version control falls under the implementation aspect of software. So along with writing our code, we're going to be using a version control tool to assist us in running our code. So what are some problems we're trying to solve when we're using version control? And these are non-technical problems. Well, I want to be able to experiment with features without ruining the working code. So write some code without breaking the working code that exists. I want to be able to also trace the origins of bugs that I didn't encounter from before. In doing so, I can find out when it happened and where it happened and in what context. Collaboration with developers as well, that's a very common problem in software projects. So how can I collaborate productively with other developers on the same source code so that we can split up the work and they can do this and I can work on this particular problem. And finally, I want to be able to, how can I roll back to a previous version or to a previous working version of my software or my product when an unexpected bug occurs. This could happen in a feature that we just implemented and encountered an unexpected bug when the consumer was using it. So how do we so rolling back is a problem we face during implementation. So version control helps in all those aspects. We can track changes to our source code over time. That's kind of the fundamental existence for version control. So because we can track changes to source code over time, we're able to roll back to previous versions of code. We can view a complete log of changes to the code, including the date of when changes were made, who made the change, and what exactly was changed. And version control also enables productive code collaboration. So it goes a long way to providing collaboration. So now let's take a look at the fundamentals of version control. The most fundamental concept we need to understand is the concept of a commit, which is essentially a snapshot of our code. So taking a picture of what our code looks like at a current point in time. Now, what code do we mean? Well, that's what we mean by tracking changes. I'm able to choose exactly what files I want to keep track of, or I want version control to keep track of, such that we can create commits and snapshots for that code. And as a result, because I'm creating multiple commits for the same bit of code or for the same files, then I'm able to view change logs and view a series of commits of all the changes we made, all the snapshots we made for our code. Also, I want to be able to do what's called merging and branching. In other words, I want to be able to branch off of my main code and able to work in isolations, allowing me to work on experimental features. And then I want to be able to diff, or diffing, or seeing a differential between a before and after version of my code. So if I've added 100 lines of code, I want to be able to see a before and after view of that code, so I know what exactly I'm adding. And finally, to enable collaboration, I want to be able to resolve conflicts between multiple developers who are contributing maybe to the same file and have edited the same function, right? I want to be able to resolve those conflicts productively so I can keep working on the project. So those are our fundamentals laid down, and all these examples of version control kind of implement those fundamentals. So we've got Subversion, we've got Git, and we've got Merkle. All of these kind of implement those fundamental principles that I mentioned earlier in their own unique way, and are used by developers in many different ways. A project will usually use one version control, but it's not completely uncommon to see multiple different version control using, especially if it's an older company who might have used an older version control system such as Subversion. Okay, so we're going to be using Git in the course, and to install Git, I'm going to walk through the three main operating systems with installing them. So for Linux, just run those two commands one after the other. So do a sudo apt-get update followed by sudo apt-get install Git, and we should have Git installed on Linux. For Mac OS, go to the App Store and install Xcode. It's around a 5 to 6 gig install, so it is quite large. And for Windows, you can go to either this link, or you can install Bash for Windows from the Windows Store and just open that application and just follow the Linux instructions. So once you've followed the instructions, to check that you've got Git working, go into your terminal, which is where most of our work will be done, and type in git -- version. And we should get the version number of your Git software. It doesn't really matter what version it is. Version 2 and above should be fine for the course. You don't need to also write Git version. You can just write Git in general, and you should come up with a bunch of instructions. As long as you don't get command not found, you've got Git installed. In our next series of videos, we'll focus on actually using Git and applying those fundamental principles and solving those non-technical problems we encounter in software development. Hopefully, we can improve our engineering. Thank you very much.